Welcome back to BarnesBasics, and the next ionic reaction that we're going to work is one between silver nitrate and barium chloride. Remember that if you have downloaded a common oxidation number sheet and a solubility rule sheet as outlined in the first video of this playlist, you did right. If you haven't done that, please download those, and then that way we'll have a good experience right here. Then you'll be able to follow me pretty nicely. In ionic reactions, they are called exchange reactions, and so one positive ion matches with the negative ion on the other compound. So when we look at the products here, on the product side, we're going to get silver chloride and we're going to get barium nitrate. When we look at each one of these formulas, we can know the symbols and the oxidation numbers by looking on a common oxidation number sheet or a periodic chart. And so I know that silver nitrate, silver is +1 and nitrate is -1. I know that barium is +2 and that chlorine is -1. And I know that silver is +1 and chlorine is -1. I know that barium is +2 and nitrate is -1. So before I attempt to balance this equation to work toward a net ionic equation, I need to make sure that each individual formula is balanced as I go. So that's what we're going to do next. There is a +1 and a -1 that balance here. We're good to go here. When we look at barium chloride, two -1 ions make -2. This cancels. This is neutral. Looks like we're going to need two nitrates here. Two of those at -1 makes -2. That cancels. We're good to go there. So now let's go through and balance this chemical equation. I see one silver, one nitrate, and two nitrates. Let's always let's spring for the easy fix here. Let's say we're going to put a 2 in front of that nitrate. And so now we have two silvers. Okay, I guess we've got to come over here and work on that side for just a minute. Two silvers. We've got two silvers and two silvers. Two nitrates. One barium, two chlorines, and two chlorines. It looks like we are good to go here. Looks like this is balanced. The next thing I want to do is I want to look at each one of these compounds and try to determine which one is soluble and which one is insoluble in a water solution. Remember, these ions, a lot of times they dissociate or fall apart in a water solution. And so we know that rule number 1 says that all nitrates are soluble. So I know that this is soluble because of rule 1. Soluble, rule 1. And as far as chlorides go, there is a rule that says all chlorides, bromides, and iodides are soluble except for silver, lead, and mercury. This is not either any one of those. So this is soluble because of rule 3. Rule 3. When we look at silver chlorides, remember that it was the same rule. It said all chlorides are soluble except silver chloride. So we're going to say this is insoluble according to rule 3. And then barium nitrate. Again, we've got a nitrate, and remember, we know that all nitrates are soluble according to rule 1. Soluble, rule 1. Now, the reason I do this step is so that I can determine the net ionic equation. And so I'm going to go ahead and drop this down. I know it's insoluble, so here's my precipitant. I'm going to put two silver chlorides, and I'm going to write them as a solid. And one of the next things that I'm going to do is go ahead and write the ionic reaction. I'm going to write all of these separate ions. So in the ionic equation, we have two silvers that are +1. We have two nitrates that are -1, and they are also aqueous. Let's write that down. We have a barium that is +2. It is aqueous. We have 2 chlorines that are aqueous. And I always do that. AQ, and that's -1. We, on the other side, we'll just keep this the same. 2, we're going to just say there are 2 silver chloride solid, 2 moles of that. We're going to, or 2, let's just say 2 moles of that. That's the simplest way to talk about it. We've got 1 barium on this other side. It is aqueous. And we have 2 nitrates. And I'm kind of running out of room. I don't really like that. Really would be best right over here, but I'm running out of room on my chart. So when we look at this, we saw 2 silvers, 2 nitrates. We saw 1 barium. We saw 2 chlorides. We saw 2 silver chlorides, 1 barium, and 2 nitrates. So that would be the ionic equation. And we've got aqueous, 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 solid, aqueous, and aqueous. In the net ionic reaction, we only write in the chemicals that make silver chloride. So we would write 2 silver aqueous moles of aqueous ions, and we would write 2 moles here -1, create 2 moles of silver chloride precipitant. The ions that don't participate, they can be thrown out or not necessarily thrown out. They're just marked as spectators. They did not participate in this net ionic equation that resulted in a precipitation reaction. Marvelous, very good. Silver nitrate and barium chloride, yielding silver chloride and barium nitrate, with silver chloride being the precipitant.